let's just briefly recap this, what we just spoke about. Make sure you're all happy with it, and then we can talk about what to do next. So we had what I've done is I've just updated the colors to hopefully make everything a little bit clearer. We had some equilibrium level of aggregate expenditure, AE0. That was our equilibrium point. Let's give it a name. Okay, this is our initial point. Equilibrium initially at point, I don't know, what do we want to call it? E, something. Okay, equilibrium point E. We had some level of government spending, G0. We increased government spending to G1. That increase in government spending increased aggregate expenditure. Shifted our aggregate expenditure curve up. It shifted it up by the change in government spending. In other words, the increase in government spending shifted the curve up by that distance. That distance being the change in government spending. If we consider point A, in other words, at our initial level of output, but with our higher level of aggregate expenditure, right? We would have some level of expenditure AE1 given by our initial level of consumption plus our new level of government spending, which was much greater than our actual level of output. So what happens from point A is that we have a movement towards our new equilibrium point. Let's call it point C, I guess. We have a movement from point A to point C. Point C, we have aggregate expenditure level AE1E and Y1E. Maybe I should refer to those as C. I will neaten that up a little bit just now. Let's just call those C because it makes more sense. We're at point C. Which means at point C we have, once again, equilibrium between aggregate expenditure and output, given by consumption at that new level of output and our new level of government spending. The increase in government spending itself, if output just increases to match that increase in government spending, so from point A I just draw a horizontal line to our 45-degree line and then down to our x-axis measuring output. If output were to increase just to match that increase in government spending, right, we would have this increase in output given by this yellow distance. Okay? So what I was saying here was this change in output is to match our change in government spending. We need that much more output in order to balance the books, so to speak. In other words, in order to match the new level of government spending. We must increase output to match the increase in government spending. That is this yellow distance here. However, we know that consumption has an induced component. So what happens is with that increase in output generates an increase in income. That increase in income leads to a further increase in consumption. That increase in consumption generates a further increase in output, right? And that is this blue component here, or teal component, or cyan, whatever you want to call it, right? This blue is now the induced component. In other words, because there was an increase in government spending, there was an increase in output to match that increase in government spending. However, that increase in output generated extra income, which led to an increase in consumption. That increase in consumption led to a further increase in output. That is called the multiplier effect. So that the entire change in output is this distance y1 minus y0. This is our change in output, which is made up of an initial change in output to match the government spending plus additional induced changes in output because of a change in consumption. Okay, and then I just used the colors in these equations to match what was going on, and I will just make any changes that I've missed along the way. Okay, everyone happy with that? Okay. So what we've just drawn was essentially what is described in this slide where we're talking about the multiplier. It says the amount by which a change in autonomous expenditure is magnified or multiplied to determine the change in equilibrium. Okay? The multiplier effect, the change in autonomous expenditure leads to an amplified change in equilibrium expenditure. Equilibrium expenditure increases by more than the increase in autonomous expenditure. Okay? The increase in output was more than the increase in autonomous expenditure. The yellow change was the increase in autonomous expenditure. The increase in output was the red change. The red is greater than the yellow. Okay? That's what we're referring to. Why is the multiplier greater than 1? Because of our induced expenditure components. Because in our diagram or in our equation, C is an induced component. In other words, it depends on Y. Any change in government spending or any change in any autonomous component leads to a change in Y. That change in Y leads to a change in C. That change in C leads to a further change in Y, and backwards and forwards. What is the size of the multiplier? Well, to calculate the multiplier, we divide the change in equilibrium expenditure by the change in autonomous expenditure. In other words, here's our multiplier. Okay. We've seen already that the multiplier and the slope of the aggregate expenditure curve are intimately entwined. The slope of this aggregate expenditure curve, if we take it as a simplest case, would be B, then the multiplier is 1 over 1 minus B. Right? So if the slope equals B, then our multiplier would be 1 over 1 minus B. If, of course, in this example, consumption is the only induced component. If there's also induced taxes, if there's also induced imports, or if there's induced any other kind of component, then the multiplier would be different. What we see comparing these two different graphs, here we have a slope of 0.75. Here we have a slope of 0.5. A slope of 0.5 leads to a multiplier of 2. A slope of 0.75 leads to a multiplier of 4. The steeper slope leads to a higher multiplier. Okay? So if you wanted to take that to an extreme, if you had a perfectly flat slope and you had an increase, right? So this is entirely horizontal. Oh my goodness. Okay, so all of these slopes are, all these lines are horizontal. So AE0 and AE1. This is perfectly elastic. Perfectly elastic. Then what would the multiplier be? Remember, the steeper the slope, the higher the multiplier. The flatter the slope, the lower the multiplier. Perfectly elastic, is that very steep or is that very not steep? It's not steep at all, it's completely flat. It's the flattest you can get. Okay? So if it's the flattest you can get, what do you think the multiplier is? 0. Cool. Then in terms of the multiplier, what happens when you have, say, induced imports? So now we're talking about induced imports. And when we're talking about income taxes, the kind of income taxes they're talking about here again are induced income taxes. Yeah.
So Nick, I actually have a question. I'm
Yeah.
wondering, so obviously a country would want their economy to grow, so they would want a large multiplier, if I understand.
Okay, yeah. I mean, a larger multiplier would just mean, sorry, I'm being sitting here. A larger multiplier would mean that any change in an autonomous component, like for example government spending, would lead to a greater effect in the economy, a greater growth effect in the economy. Yeah?
Because you actually really answered my question, because I was going to ask, so what can we do to actually make our multiplier larger?
Okay, so actually making the multiplier larger, yeah, I mean that's a tricky question, because remember the multiplier is B. I mean the multiplier depends on B, right? So that says BY. How much do we consume of a change in income? So the answer to your question, given what we've discussed so far, right, is by making people just consume more, our economy will grow more. Okay? Which doesn't necessarily seem intuitively correct. Because what about savings, for example? Aren't savings important? Aren't savings important for, say, investments, right? We just treat investments as autonomous, right? Autonomous in our example. It's just one of those which means doesn't depend on Y, okay, directly. And what that means is that essentially savings in a roundabout way are also treated as autonomous. So, because if savings are autonomous, right, this value B is also treated as essentially, I won't use the word autonomous here, I'll just use the word exogenous because it makes more sense. It's an exogenous variable. In other words, B is determined outside of this model. Nothing inside the model tells you what B is. You have to be given B. Or given other data, you have to calculate what B is. So the idea would be, how do we change this exogenous B, which also then has an impact on I and S and other things, right? So at this stage, there's quite a simplistic answer, which is, yeah, cool. Increase B, great. We increase our multiplier. Surely that's a good thing, right? That answer is far more nuanced once we've introduced a lot of other components. But yeah, at this point, make B bigger. That's cool. That helps us. Yeah. Was there another question? No? Okay. Right, so this slide is talking about the multiplier. Once we've included induced imports and induced taxes, right? What it's telling us is that they will make the multiplier smaller. But we've already seen that mathematically. Right? Sorry, wrong slide, wrong work. Here's our multiplier without induced taxes or without induced imports. It's 1 over 1 minus B. Okay? Once we include autonomous taxes and include autonomous imports, what happens? If T is now positive and M is positive, that means this entire number down here must be bigger, right? If this number is bigger, this entire multiplier must therefore be smaller. If your denominator is bigger, then your fraction will be smaller, right? And this whole fraction is our multiplier. So if we include tax rates and we include induced imports, yeah, then our denominator gets bigger, which means our multiplier gets smaller. Wrong way. Okay, so when we include induced imports and induced income taxes, then our multiplier gets smaller. Why does it get smaller? Well, there's two reasons. We can talk about the intuition there. Remember, in our simple equation, y equals c plus I, an increase in y increases c, which increases y. If we include income taxes, then that increase in y that leads to a further increase in c, right? First, what we have to do is deduct higher taxes from it. In other words, instead of getting a full increase in y, if your tax rate is 20%, for example, then the induced component only becomes 80% of that increase in y, right? So the multiplier must be smaller because we're getting less income to spend because now we have to pay tax on it. Imports are negative. So if imports are induced, a higher y leads to higher imports, which is negative for our y, which means our multiplier must be smaller. So taxes, induced taxes in terms of C, taxes are negative. Induced imports are negative. If we make the negative parts bigger, then the impact on Y must be smaller. That's the intuition that we're dealing with here. Yeah, and there's nothing else on that slide really. Here's our multiplier effect as a kind of a graph. It's showing you that obviously as we increase output, it leads to smaller and smaller induced increases in consumption, and then therefore smaller and smaller induced increases in output. So that's our multiplier process graphically. We've got very few slides left, but we can leave it at that point and then use that as a good starting point when we come back to this material to refresh our minds on how this works. Right, I mean, once we've dealt with the test and all that business. Just a couple of slides which are quite fun to use as recap stuff. So, that gives us another 20 minutes. Is there anything at this point that you can think of that you would like to talk about for the test?